Hey, thanks for taking the time to check the video. Let's run down through the code. So remove people. Let's see what it does. So it's a proof of concept for removing unwanted people and objects from images. Here are a couple of examples. So this was the original image. After running it, we got this. Same here, original image. After running it, clean. So the first thing that we've got to do is download the code. If you already know how to use Git, you can just skip this part of the video and go straight to where we're actually seeing the notebook. But let's git clone. This takes a second. Done. Okay, so we've cloned the repository. Let's go back to the documentation. So, okay, here's a brief explanation of how it works. Basically, we detect objects using a mask region-based convolutional neural net, and we use the default weights from PyTorch. So right as it comes off the box, we can even fine-tune this further and get even better results, but right now I just left it as it is. This model was pre-trained on the Coco dataset. Then we manually select the objects that we want to keep in the image. We remove them with the code and just convert a PNG image without the unwanted objects. And then we upload the PNG to OpenAI's API and we get the clean image. So first things is to install the Python environment. So let's copy that command, paste it over here, run this. Okay, so done. Now we can see that we're using this Python library. Let's see what's next. So next thing, we actually interact with some of the files that are in the code. So let's copy this command, move into the repository that we just cloned. So remove people, and we do the install command. Before doing it, I'm gonna open this in Visual Studio Code. Let's max screen this. And let's check the install command, what it does. So basically, we first install the IPy kernel for Jupyter kernels. Then we install a specific version of NumPy. This is to avoid some compatibility issues with Torch. And then we do all the other basic installs. After this, we automatically create a Python kernel, a Jupyter kernel called remove people. And with that, the setup is complete. So let's run the command. So over here, install. This takes a second, so I'm just gonna wait for libraries and fast forward. Okay, done. So this finishes the install of the libraries. Let's go back to the documentation and see what we have to do. Okay, so whenever you want to clean up, you just run this command and remove the kernel and the environment. Now you have to have the OpenAI API key in a .end file. So let's go here, just add this, so you can see the full command. I'm going to clear the screen, paste it up here. So we run that command. If we go to our our Visual Studio Code, we can see the file is created, OpenAI equals your API key. So just paste your API key here. I'm going to paste mine, but of course this is not going to be in the video, so I'm going to cut it here. Okay, so my OpenAI API key has been added. Let's go back to the docs and see what's going on. So brief explanation of the code. There's two notebooks, remove people and cloud examples. Let's just focus on remove people. Cloud examples is just object segmentation with APIs from AWS and Google Cloud, and then running the notebooks. So we finished setting up the environment, that's done. Then we open this in Jupyter Notebook. Let's just use Visual Studio Code. Open the remove people notebook, it's this one. Then we connect the remove people kernel that we just created. So we go over here, select kernel, Jupyter kernel, remove people, it's the one that we just created. Let's select this one. Okay, and now we can start running this stuff, see what happens. So what we have to do is we have to import the image that we want to use. So here I have two example images in the original section. It's this one and this one, the ones that appear in the documentation. So we can actually upload a new one. I'm going to open up the terminal here, or well, let's just go to the terminal that's over here. So I'm going to copy a file from, it's called friends.jpg, and I'm going to paste that into the images folder here, original as it is. Okay, so you've got it here. It's this photo, so I want to remove this guy and this family over here. So let's go back to the code. So we want to use friends.jpg, run this. Okay, so the imports are done. Then we load the model that we're using from PyTorch. Here's an explanation of the architecture of the model. It's a mask RCNN. It's actually on a paper from Facebook, so you can check it out here. Let's get back to this. And these are some miscellaneous functions. We can ignore them. So we pre-process the image to convert the file into a vector file that we can actually plug into the neural net. And then we apply the mask of the objects that we detected over the image. So we'll see those in action in a second. Now we actually apply the model. We use no gradient for inference. And yeah, let's run it. So this will show us the original image in one side, and in the other side, the one with the mask of all the detected objects. So here it is. This is the original, and these were all the detected objects. Now we have to manually select the objects that we want to maintain in the image. Okay, so this is probably the longer process, but it works, and I think it gives you some degree of flexibility right now. So these are all the objects that were detected in the image. Here we can see the main objects. It's definitely person number 1, this one. Number 2, we want to keep this too. Then the image has this thing over here. We probably want to keep that thing. It's not that much noise. So if we find that one, it's this one, 21 and 22. So let's keep 1, 2, 21, and 22. So we go down here and we plug it in. 1, 2, 21, and 22. And this will create 2 masks now. So this is a mask of the protagonists, the thing that we're keeping in the image, and this is the things that we're removing. So then we create a PNG out of this. So here it is. This is the protagonists, and all of this white space, it's what is going to be filled in by AI. And now this one's optional. Right now this image is already of the accurate ratio that this expects, but it's basically a 1:1 ratio. Try to keep images to a 1:1 and it will be okay. If not, this is going to change the size to something that the OpenAI API accepts. If you change the provider to use something else rather than OpenAI and they accept different image ratios, I mean, it can work with anything. And once we do that, we just run the OpenAI execution and download. So basically here we're, oh crap. Okay, let's stop this execution right now. Because here we have to have a prompt, right? So let's just complete the image with a plain background. Previously we had this other prompt that I used for one of the examples. Here the n number is the amount of images that it's going to generate. So every image that you create with OpenAI will be different because it's like generative AI and it's always changing the results. Like it's not predictable. So let's run this. Here's the size that we're using. You can read the OpenAI docs on how this works. They're linked right here. So basically we're using the image edit API. Oh, this link. Yeah, so here, create image edit. It's this one. Here are some of the things that you can play around with. You can try it out. Right now you can only use DALL-E 2, but whenever we can use DALL-E 3 or whatever future model, it's going to be way better. Response format, right now we're just using URL and downloading the content from the URL. So here it is. This is the results. So we have this image, and this was the output image. Then there's this additional information. You can ignore this. It's just the labels of the object detection. If you change the weights, you probably have to change this, but for now we can just ignore it. So this is a result. As you can see, it added some objects here in the background instead of like making it completely clean. The objects are caused because of the shadows. Okay, so that's a limitation. So if you can see here, there's like this small dark thing in the bottom and this other small dark thing here and here. And this, it's weird because basically the model detects that there's something there because of the shadow and it adds it up. So images with shadows, just be careful on them. But if you go for images such as the ones used in the examples, which are like this one or the other one, you can have good results. So if you add a model that can detect shadows as well, you can get even better results as well. So let's just do a run with the example one image, which gave us good results. This we don't need to run again. This we don't need to run again. This one we do run again. Okay, so here are the results, the objects that were detected. Then we inspect the objects. Basically, we want to keep the person and the couch. So we want to keep 1, we want to keep 6 to 8, which are okay. There's the couch. Let's see, anything else? We probably want to keep this 31 chair that was detected. Let's run it with those. So we're keeping 1, 6, 7, 8, and 31. We run this. So this is what we're keeping. This is all the things that we're removing. Let's see the PNG, how it looks like. So this is the result. Okay, makes sense. Then the image resizing for OpenAI, and then calling OpenAI itself. So let's see what happens. Okay, cool. So these are the results. I think they're good. And if you don't like them, you can just rerun it again. And again, the background, the filling in will be different every time. So this is how it works. I hope it's useful. And if you can contribute some code to fix either the shadow problem or use a better model for object detection, that would be awesome. Also, we could automate the selection of the main characters. I've not delve very deep into it, but there's definitely a way to do this and just like automatically get the main things. But I hope you like it and that it's useful for you. Okay.